Math 2414, Calculus 2. Calculus 1 review. Integration by substitution. Examples, Part 2. Warning, there will be a Part 3, but it will be the final video in this Calculus 2 review. Calculus 1 review. On the board I have three integrals. I invite you / challenge you to pause and try all of them. But the purpose of these is to try to identify a plan of attack. That's half the battle. Once you find your plan of attack, you just got to follow through. And of course, know your calculus, algebra, and trig all along the way. All right, so let's start with C, continuing from the previous video, which ended with B. The integral of x to the third power cosine of x to the fourth power minus 4 dx. I mentioned that when you're choosing your substitution, you should be thinking about an integration rule that you're trying to make this look like. But there's another strategy to choosing a substitution, and that strategy is to ask which part of the problem has its derivative somewhere else. Because when you find the derivative, you need its pieces to be elsewhere in the problem to cancel when you solve for dx. In this problem, it's a product, it's got powers, it's got trig functions, but the trig function is the thing that catches my attention. I know the rule for the integral of cosine of u du. It's equal to sine of u plus c. So if this is the rule that I'm going to use, then the u should be the x to the fourth minus 4. Let's try that. Now there's something else that says that's a good substitution. Let u equal x to the fourth minus 4. Now what would du equal? Well, the derivative of x to the fourth minus 4 is 4x to the third power dx. And if you'll notice, there's already an x to the third power in the problem. That's kind of important because when I solve this for dx, there will be an x cubed underneath here that will cancel that x cubed. So dx would equal du over 4x cubed. Now we're not doing a definite integral, so we don't need to fiddle with limits of integration. We'll save that for that one over there. But let's take inventory. Let's see who becomes what. The x to the fourth minus 4 becomes a u. So inside parentheses, I'm going to write a u. The dx will become du over 4x cubed. Who have I not circled? The x cubed and the cosine. It's actually a nice strategy when you're pulling off a substitution, because one of the mistakes students tend to make is to lose track of pieces. But if you circle things as they undergo a substitution, then everything uncircled is still there. Now at this point we still have x's, and we can't integrate x's and u's simultaneously, but we got lucky, so to speak. The x cubes cancel. What if that doesn't happen? We'll talk about that in the next video. Let's clean this up. We have the integral. We have a 4 in a denominator. We can view it as a times 1/4 and pull it in front. We have a cosine, u, du. This has now become the integration rule. We need some equal signs in front of these. The integral of cosine is sine, so we have 1/4 sine of u plus c. And I want to show you a nice little, it's not really a trick, it's just a recommendation. When you do the integral rule, you're about to write down the u, but what's your next step? To change the u back to what it represents. So as you're doing the antiderivative, you can actually multitask and say, all right, sine of u, but wait a second, I'm about to change the u back to what it represented, and u represented x to the fourth minus 4 plus c. Now, if you want to inject the intermediate step of writing 1/4 sine of u plus c, in other words, if you want to write 1/4 sine of u plus c in the middle and then undo the substitution, by all means, that's what you do. You do what helps you understand and get to the correct answer. But if you do enough of these, you start realizing that you can actually undo the substitution immediately as you're doing the antiderivative. We could check the derivative, it wouldn't be that bad. The 1/4 would stay put. The derivative of sine is cosine. Chain rule says leave the inside alone. Times the derivative of the inside. The derivative of x to the fourth minus 4 is 4x cubed. The 4's would cancel, leaving the x cubed, and we would get back our integrand. So that one wasn't too bad. Now, this one is actually not that bad once you choose the correct substitution. The substitution on this one may not be obvious because, well, where would you go? Would you say, let's let u be everything under the square root? Well, actually, let's try that. You will have some trial and error here. Let's say that you just decide to jump in and say, let u equal 9 minus x to the 6th, because that's a big chunky thing. We can make it the square root of u. We can rewrite it as a u to the negative 1/2 power and hope that everything behaves. Well, let's see what happens if we follow this path. Then du is equal to negative 6x to the 5th dx. Do you see the problem we're going to run into? If we solve for dx, we get du over negative 6x to the 5th. And let's see what happens to our integral. We get the integral. Let's take inventory. The 9 minus x to the 6th is what we called u, which was living under a square root. The dx becomes du over negative 6x to the 5th. And who is unaccounted for? The x squared, so he's still there. But do you see the problem? Not all the x's cancel. Two of these, let's change colors. Two of these would cancel two of those and leave x cubed, and now what do I do? What do I do with that x cubed? I can't integrate now because I'm integrating u's and x's, and we don't do that in this class. This usually means you made the wrong substitution. Well, how do you know what to pick then? Well, this goes back to one of the things I told you about choosing your substitution, what you're attempting to do. When you make a substitution, you are attempting to transform the integral into an integration rule. So let's back up for a second and think about, are there any integration rules that kind of resemble this structurally? And the answer is, what about the very last one? What about the integration rule that said the integral of 1 over the square root of a squared minus u squared du is equal to arc sine of u over a plus c? I know I spilled over there. We'll fix that in a moment. Well, this integral resembles this structurally for two or three key reasons, depending upon your perspective. Number one, there's a fraction. Number two, there's a square root in the bottom. And number three, there's a subtraction problem. Yeah, 3 key aspects. The fourth one is this is a square, but the truth is any number can be viewed as a square. Like if you saw a 7, that's a square. What's it the square of? The square root of 7. So yeah, any number can be viewed as the square of something. But yeah, this is just screaming, I look like this. I know it's got an x squared up there, but that might cancel with the right substitution. So, you can probably tell over the course of these videos that my voice is cracking because I've been recording them back to back to back and I haven't taken a drink. So sorry if my voice starts cracking. But if we're going to choose this integration rule as a means for doing this integral, then we need to figure out where the u is. And this is where you have to be really analytical from an algebra perspective. If we are going to use this integration rule, then the u squared is right there. And if we match those up, u squared is equal to x to the 6th. But I need to know what u equals. Well, how do you undo a square? You square root both sides. And you get u equals x to the 3rd. Remember, a square root is like a 1/2 power. Half of 6 is 3. So maybe that's the substitution that we want to use. Oh, wait a second. What's its derivative? 3x squared. Remember the problem we had before? The x squared canceled, but there were x's left over. This x squared is going to cancel that one. This is the right path. It takes a lot of practice to be able to say, this is the substitution I'm going to use. But let's go with u equals x cubed. I'll erase this in just a second. There's one other thing I need to point out. Well, we'll point it out in a minute. We're going to let u equal x cubed because when I square it, I'll get x to the 6th and I'll be able to get here. Again, this one's a little sneaky, but the decision was based on the structure of the integrand matching the last integral rule that we had in that video. All right, if we let u equal x cubed, then du is equal to 3x squared dx. So dx is equal to du over 3x squared. Let's make all of our substitutions and then take inventory of who is not accounted for yet. Let's get rid of the red circle. All right, with this substitution, you have to be a little stealthy, a little sneaky, because if u equals x to the third, then that implies that u squared is equal to x to the sixth. So the x to the sixth is going to become a u squared under the square root after the subtraction problem. The dx is going to become du over 3x squared. And who is unaccounted for? The 9 minus and the x squared on the top. With that choice of substitution, and again, it was not the obvious choice, but it was driven by matching the structure of this problem to the structure of the rule that we're trying to match it to. By that choice, the x squareds cancel, and that fixes the dilemma that we had before. So let's see what we have. We have a 1/3, so we can throw that in front. Integral. Nothing left on top, so we write a 1. Square root of 9 minus u squared du. Now I'm going to rewrite the rule that we had before. Integral 1 over the square root of a squared minus u squared du. And the reason I'm writing it is because not only do we have to know what the a is, the u is, but what the a is. This, of course, was arc sine. I keep leaving the c out. Arc sine of u over a plus c. If we're going to use that rule, we also have to figure out what a equals, but it might be pretty transparent. The a squared resides where the 9 is, which means we need a squared equals to 9, which means we need a is equal to 3. Technically, it can be positive, negative 3, but this integral rule did stipulate that the a was positive. All right, so let's do the integral rule. All right, we got to keep up with everything. Got a 1/3. Integral rule says arc sine of u over a, but the a is 3, so u over 3 plus c. Almost done. We got to replace the u with what it equals, but it just equals x cubed. So 1/3 arc sine x cubed over 3 plus c, and that problem is over. Not all substitutions jump out and say this is the substitution to use, but the structure of this problem drove the substitution. You just got to watch your algebra. Now, if you're wondering why I'm wondering back here when there's one problem left, because I'm going to take that problem over there with one other problem and make video 3, if I can get it focused. All right, so we'll do that one and then one more on video, part 3 of this.